Welcome to Automating Your CI/CD Pipelines. My name is Alexis Abril, Senior Partner Engineer at GitHub. This is the first in a series of virtual summits exploring how GitHub and our partners collaborate to increase your engineers' efficiency, security, and productivity. In tech partnerships and engineering, we focus on enabling partners to integrate with GitHub as a platform and, as a result, enabling you. We'll be focused on GitHub Actions today and are joined by an incredibly exciting panel of partners with HashiCorp, LaunchDarkly, Datadog, and OctoML. Our first presentation today is how to build security into enterprise pipelines with HashiCorp and GitHub.
Hi, everyone, and thanks for joining us. My name is Ray Plosky, and today we'll be speaking about how you can build security into your enterprise CI/CD pipelines with HashiCorp and GitHub. My name's Ray. I'm Field CTO for HashiCorp. Chris, why don't you introduce yourself, and Justin as well.
Thanks, Ray. Hi, everyone. Chris Reddington. I lead our enterprise advocacy teams across Asia and Europe at GitHub.
Hello, I'm Justin Giray. I'm a solutions engineer here at HashiCorp, helping out our enterprise in the West region.
Great. So jumping right in, a lot of the focus that we've been working on lately is time to delivery and making sure that our organizations move quickly. Mature DevOps orgs are decisively outperforming their peers nowadays. There's a set of metrics out there by the DevOps Research and Assessment Association, or DORA, that talks about how often we deploy, how often we actually commit our code to when we actually see it hit production, how often we make a mistake, and how fast can we recover from that. And it's pretty much split up into various different quartiles. And you'll see that those that are elite performers are deploying once or more per day, that they often have a lead time of a short commit within an hour, and that they really don't make as many mistakes as the lower quartiles at this point in time. And while that might seem like nice in fiction and great for marketing, it's actually a fact in the industry. It's not a fiction. So you'll see more and more of the organizations out there in the industry starting to be able to have these rapid deployments and quick turnaround times. And we're actually learning from our practices, so it's relatively promising. And if you don't believe me, believe McKinsey, who talks about the fact that anyone who has a high developer velocity index, they'll outperform their peers by 4 to 5 times when it comes to revenue. So I set a bit of stage around why we wanted to be able to bring velocity to the enterprise. In HashiCorp, we establish a premise that it really revolves around building out a platform so that you can meet your developers as customers where they are to make sure that they can move quickly with some potential guardrails around that. What's interesting is the world has changed significantly from 10 years ago, when most of the applications that we saw deployed were in a private data center. And there were specific ways that one could actually manage that, whether that's a vCenter for VMs and IP for security with ports and hardware for that as well, and how we connected all these different pieces together. Nowadays, while many of these private data centers still exist and run our systems of record, oftentimes you'll see people have a primary or a secondary or a multi-cloud approach where they'll be adopting all sorts of different services. What's challenging is that the operating model, or how we conduct our day-to-day work, is very, very different, whether you're running on AWS or Azure or GCP, and what that might look like. HashiCorp's unique value proposition is that we have consistent workflows. So whether you happen to be on-premise or in the cloud, you're able to provision consistently, whether that happens to be telemetry from something such as Datadog, the ability to broker your identity from your Azure Active Directory to your AWS IAM, and make sure that you can manage the credentials and secrets and rotations on the fly on a regular occasion can be done with Vault. And last, to be able to connect these existing estates with what you actually put into your various different availability zones around the world, and make sure that you can discover your services, make sure they're healthy enough, and have some real intentional commands of what particular microservice can talk to what console comes into play. But at the end of the day, what you're looking at is a set of platform teams that are defining a set of infrastructure for your app dev teams so that they can commit their app code relatively cleanly and consistently, have self-service, be able to commit quick and provision out on the fly with the best model and best of breed of what your platform team defines for your enterprise. Think of it like falling into the pit of success. Sensible defaults for your developers to move very, very rapidly, quickly, whether that's provisioning infrastructure, securing your enterprise, connecting all these different pieces together, or even being able to run many of these different types of services. So Chris, I talked a lot about what the Hashi stack is and what we consider a platform team. Can you tell us a little bit about GitHub Actions?
Sure, thanks, Ray. I guess adding on to everything you've said there, when we think about these platform teams and this idea of building platforms, doing things manually doesn't really work at scale anymore. We need to start automating things. We need to start operating in a way where we're operating for that scale. And GitHub Actions can really help us with that, whether it's automating based on GitHub events or for your CI and CD workflows. So we're going to look through this webinar as well, how GitHub Actions can work with some of the HashiCorp stack. So if we move on to the next slide here, there's a few key points that we really think about with GitHub Actions. The first, the best developer experience. The workflows themselves are actually defined using simple YAML syntax. And what that means is the code for the pipelines lives right next to the code for your applications or for your infrastructure. So what that means is you can think of those build and deployment pipelines evolving over time as you evolve your application code or your infrastructure as code as well. And the additional piece is that they're extensible. So it's easy to build workflows that can be reused across the organization. So once you've defined that pattern once, you can use GitHub Action reusable workflows across the organization with each of those development teams or application teams that maybe are building on the same infrastructure stack, building with the same frameworks, etc. So teams don't have to keep reinventing the wheel. It's platform native. So GitHub Actions integrates across many of these GitHub events I alluded to earlier, whether it's reacting to GitHub issues being created, updated or deleted, or a push or a branch or a pull request, like we'll see a little bit later. It's equally embedded in our mobile application. So if you're out on the go and there's something that maybe you need to cancel a running job, for example, you've pushed to production and realized that actually maybe you shouldn't have done that, you can actually go and make some changes via the mobile app there as well. You can scale simply and scale securely. So if you need to enforce policies across your organization, maybe which GitHub actions you want to be allowed within your organization or disallowed, or maybe you want to use GitHub hosted runners that are suited to your needs. Maybe you want to self-host some runners in your own environments. There's that level of flexibility there that is available for you based on what your needs will be. And one of my personal favorites, and I'll be a little bit biased, I wrote a blog on it recently, is all about OpenID Connect. So one of the things I think about with many technology teams is toil. It can be a big challenge. And GitHub Actions and OpenID Connect can enable teams to deploy to cloud environments without using password, which I believe we're going to see a little bit of here later as well. And then finally, dev community driven. You can build on the work of partners like HashiCorp or the wider open source community. Take a look at the GitHub Marketplace, because there's over 17,000 GitHub Actions available in the marketplace right now. So there's a lot of value that you can actually go and take right at this moment. So that's why GitHub Actions, Ray. So I think let's see what we've got in store for today.
Outstanding. Thank you, Chris. So Justin's been working away on making sure that we have a cool demo to show you today. Justin, you want to talk a little bit about the points, or do we want to go to the architecture, or share your screen right now?
Yeah, I think let's talk a little bit about that. So as Chris mentioned, what's really important with the way we hook up all of these technologies together, right, is to make sure that we're not leaving static secrets around. We're making this dynamic and enabling teams to be as secure as possible. And that's really where OpenID Connect comes in. And that's what we're going to be seeing today, both as GitHub Actions connects to HCP Vault to pull a secret down, as well as a little bit later on when Terraform and AWS communicate via OIDC to exchange credentials and make sure that we're not, again, storing individual secrets and access keys around. So the demo itself, as we kind of go through this flow, there's two pieces to this. The first piece is going to be, we're going to kick off a build and show how in a traditional developer workflow, you could be working with something, say a Docker image. In this case, we're going to have a little Ruby file that when it first builds, sets a secret that just says we need to replace this. The GitHub action will go out. It's going to connect securely to HCP Vault. It's going to retrieve a secret, rebuild that Docker image. And in this case, I'm using a self-hosted runner here on my machine. So that's just going to push that Docker image locally to my machine. But obviously, this could be pushed up to Docker Hub, or this could be integrated with HCP Packer. That new image then contains that new secret. So we're going to see how that works. That's also going to kind of show a little bit of some of this fine-grained control. And that what this is going to show is we only want certain types of actions to take place when certain paths change inside of our repo. In this case, because of this demo, we have both Terraform and Vault in the same place. So we only want, if we change a Vault file, we only want the Vault actions to run, and similarly for Terraform. You could also kind of go through and set that up to where individual branches are the only thing that you want to run, right? So if we're monitoring just HCP Vault branch and code is changed there, only an action will trigger if that happens, right? And then I think that's kind of, I've covered that third bullet there. And then outside of that, what we're going to be provisioning is we're just going to be provisioning a simple S3 bucket today. But again, that workflow goes back and forth with AWS, with OIDC to make sure that it's getting the right credentials. And then the bucket is going to be locked down accordingly.
Sounds awesome, Justin. I'm going to stop sharing my screen and pass the baton over to you.
Sure. Okay, so for the first pass at this, like we said, we're going to kind of go through the Vault side of the house and take a look at this. Now, I've currently run a couple of these actions. We can actually see what those look like. In this case here, I just ran this, but we'll do this live again. As a change came into my very specific branch, we went ahead and ran through several different actions. The first one was we went ahead and checked out our code. Then we built the first stock image. In this case, some of those things were cached, but you can see here that once that image was built, I went ahead and I just ran, a command so we can see it in this one place here, that this secret is indeed not secure. This was something we built off the command line and not being pulled from HCP Vault. Once we go through and import our secrets from HCP Vault, which the connection happens all at once there, and that can be configured through the secrets section in your settings inside of your GitHub repo. You configure a few fields there. That secret is then brought back in and we build a new image. So I will go ahead and kick off another build real quick here. Just go back here. You can see that lots of testing over the last few days. And we will kick off this live build. I am just going to push this now. So that is synced. So GitHub will see that code came in. It's going to kick that off. And we will have a listening runner. You can see that my self-hosted runner actually picked that up. And by the time I scrolled the window here, it was already completed. So it went ahead, picked that job up. And again, you're going to see the exact same output here. It did the exact same thing on that build. But the important part here is that when we actually go and retrieve that new secret, we can see that this secret was actually provided by HCP Vault and not the initial one we built. So in order to connect that in, just to kind of show this off super quickly. So down here in secrets and variables, there are just a few things that we actually need in here. The Vault secret and role ID are not required. This was some initial testing. What is in here that we do need is the Vault OIDC role, and we just need a URL to Vault. At that point, Vault takes care of everything within the action itself, and we no longer have to rely on a long-lived secret ID or a long-lived token ID. This is extremely important inside these CI/CD environments.
Justin, you keep on saying HCP Vault. Want to tell the audience what that means?
Sure. So HCP Vault is our SaaS managed instance of Vault, where we as HashiCorp run the cluster up in the cloud for you. It allows customers to get involved with Vault extremely easily, stand that up and start working and storing your static secrets as well as generating dynamic secrets to secure your environments.
And all you needed was the OIDC role and the URL to point it to, huh?
That's literally it.
Pretty cool.
Yeah. If you're interested in that code, obviously this repo will be available, but it is extremely simple. It is, I mean, it couldn't be any easier. We secure JWT here, JOT as you were. There is some setup required on the Vault side, right? It needs to, with the way OIDC goes back and forth with those handshakes, you basically set up on the Vault side, okay, I'm expecting this particular token from GitHub, from this particular repo and this particular branch, and you can be as specific as you want there. And Vault will obviously approve what it's given based off what GitHub is sending it, and then provide the appropriate credentials. There are several Learn guides available out there. We'll make sure to include those inside the README here, so you can reference those as you're trying to build those out. And for the Terraform side, it's fairly similar, except slightly different. So in this case, we're going to interact with Terraform Cloud. And Terraform Cloud is the same Terraform you know and love, but again, it's managed by us at HashiCorp. And this allows you to store your remote state and variables and everything securely in the cloud. Again, easy to manage and get your builds up and running. So when all we're going to be doing is deploying a simple S3 bucket, but this workflow is a little different. So this one's a little bit longer. We are looking specifically at the S3 bucket path and on a push. So there's actually a really good diagram that shows kind of what this flow looks like. And that, because we're kind of using two different steps here. The same kickoff point, whether it's a pull request or whether it's a merge to main, does two different actions. And we can see that kind of in the code. But that allows us to keep all of our code in one spot, super concise. Any PR that we see will start your Terraform plan, move through the process, but it'll just leave it at plan. It doesn't actually apply anything. Only when you say, yep, no, this is good, this looks great, and we actually merge that PR into main, does it actually continue and kick off the full apply. And all of that is going to be called, because GitHub and Terraform are talking together, again, via OIDC, all of that happens in Terraform Cloud.
And what I'd love about what you just explained there, by the way, is what we can even do is use features like GitHub branch protection rules to put gates in place so that any pull request that goes from a branch to the main then has to adhere to a certain set of criteria as well, beyond the scope of what we're talking today. But, you know, it's all about bringing those checks and balances along that process as well. So really awesome to see.
Yeah, so we have our particular GitHub, we have a workspace here with our GitHub demo. There's actually no resources at the moment for this, I don't believe. This workforce does not have any resources at the moment. So I will go ahead and kick off another branch, or do another pull request here. Okay, so I've just gone ahead and committed to my GitHub repo. So I can come over here and create a new pull request for my Terraform branch. In this case, it's just a simple change to our variables config, but that doesn't really matter. Go ahead and create that PR. And what we're going to see here is, as it checks to see if we do have any conflicts, the next step is our GitHub action takes over. And we can see that this check is going to do its thing, and it's going to walk through that workflow that we said. Once it completes that, the GitHub action is actually going to add inside of this PR. It's going to create a comment with kind of the highlights and the summary of what that Terraform plan came up with. So we can actually pop over here real quick, see that it's running through all of its paces. It's doing format, init, validate. It's going to run through its plan. This will just take a second. And when it does that, it will update the pull request. And we, as I said before, because this is just a PR, we aren't going to run the apply phase. So this will actually be skipped, and we're going to go right down to the post-checkout phase of the post-checkout job.
Oh, and you see that we've put in the cost estimates for what you can do on Terraform Cloud.
Correct.
Hey, can you show the output of the plan from Terraform Cloud as well?
Yeah, absolutely. So because this is triggered over here on Terraform Cloud, that same output is also going to exist over here. So you can view our runs. This one just finished a few seconds ago, so this should be the one. And as you can see, it was a standard Terraform plan. We're going to create an S3 bucket. We have our cost estimation. In this case, it was estimating for a bucket policy, and those are free. So there isn't really anything to estimate there. And this is also where you would see those Sentinel policies, if I have one in here, right? And we do strongly encourage you have those. In this case, make sure your S3 bucket is not public. That's probably something you want to do unless you're serving a web page or you have a rational reason for having a public S3 bucket. So now that that's done over there, we kind of come back in here to our PR. And this is that comment that GitHub Actions has created. You can see that it was formatted correctly, initializes, and we can actually see the plan output right here in the comment. And I can say, yeah, you know what? I think that that's exactly what I want it to do. I'm going to go ahead and merge that PR. And now that that's merged, we will have yet another action, right? Because if you'll remember, there was the action for the creation of PR and the action of the merge into main. And that's exactly what we can see here. Branch main kicks off, and our new Terraform is running. We get Terraform init, validate, plan's already done. And so we can just go straight to apply. In this case, our infrastructure will be created. And again, you can pop back over here into your runs and see this happening in real time if you wanted to in the Terraform cloud.
There's some really interesting things to pick up on here just in the demo. So passwords aren't being used anywhere. We're using OIDC behind the scenes to authenticate. Think of all of that manual time if you're listening in, like the things like this would have taken. And now it's just a code change in a repo through a pull request. All these things we used to from a dev perspective, we're bringing those same practices over into our ops side of the world as well and automating all of that. So removing that toil that we talked about earlier. Really cool.
Yep. Yeah, we can see here that our apply is finished. And similarly over here, the action, of course, has finished that. So if we come back in and refresh what is around, looks like we have some AWS buckets, policies, and versioning blocks. And the only thing that we're really required in there for those OIDCs is my variables. No, they've moved all this around. Sorry, my apologies. We really just need to set up that we want to use the Terraform auth provider and that we would run this with AWS, particular ARN, and all of this is handled behind the scenes. When we want to create this stuff, it goes out, creates the IAM role that ensures whatever policy you want. In this case, we say your S3 list bucket, get object, and put object. Those are the only things that this role is allowed to do. So even if someone does try to go change the Terraform code around to make these more public or add additional rights, and that won't allow this because the role that we've specified will allow that to fail. So this is kind of how easy it can be to integrate with GitHub Actions and allow both secrets to be pulled in from Vault, as well as to execute your Terraform workflows, all within the safety and comfort of the GitHub that you know and love.
Outstanding. And so when the boss says, so what? Why do you bother doing all this work? A lot of the stories around this are around simple commit. You can automate your entire construction of your infrastructure. You can have it very fine grained control with the security of the roles, as well as you can rotate your credentials out or the secrets from the apps and never have it committed into the source control. Thanks so much, Justin. So we walked through a workflow where typical code requests can come in, go through a pipeline, get secrets, apply, plan, apply, and approve and provisions infrastructure. But a lot of people ask us a lot of what is the difference between GitHub Enterprise and regular GitHub? And the same with HashiCorp Cloud Platform and Terraform, and how do they differ from the open source projects? Before I jump into the Hashi side, Chris, can you talk a little bit about GitHub for me?
Sure, of course. I think from the GitHub perspective, if you've used GitHub for open source projects, public projects, you probably know a lot of the functionality. And if you think about things like OpenID Connect, deployments, etc., some of the things we've looked at throughout, there's a lot of rich investment there that you can actually go and use for your day-to-day development. So why not use the GitHub you know and love from your open source perspective for the day job? So things like these workflows using YAML, things like having policies across the organization to allow or disallow certain aspects happening. OpenID Connect, branch and environment protections, and much more to automate those manual tasks, reduce toil, and ultimately make an overall better development experience.
Great,
Ray,
thanks
how
for that,
about the
Chris.
HashiCorp side?
From the HashiCorp side, cloud.hashicorp.com is HashiCorp Cloud Platform, and it allows you to be able to spin up Vault or Boundary or Waypoint or Console and many of our other projects very, very quickly without having to do the installation and all the work for yourself. So you can get up within 5-10 minutes and have a full cluster available for you for managing your identity across your entire estate. Similar, Terraform Cloud was our previous SaaS offering, which stands apart from the HashiCorp Cloud Platform. But much like Git has an open source library that's command line, and then we all know and love GitHub with all of its collaboration features and security and roles, Terraform Cloud provides you with a lot of that collaboration work that you need once you start to have more than a couple of people touching the infra and the state. It holds in versions and encrypts your state files. It keeps it highly available. Role-based access controls for certain people to be able to define new modules for storage, for networking, for telemetry, and the like that your app teams can then consume. Has the ability to put in things such as policies, whether that's with Sentinel or OPA, that allows folks to make sure that they are mitigating as much risk as possible and that things are configured correctly as best as possible. So it removes a lot of that cognitive load and that toil that was in place. And you can get your free version of the account today. It's pretty straightforward. So the last thing is, great. Now, awesome demo, Justin. We've talked a little bit about it, but here's some things that you might like to be able to take a look at, whether that's how GitHub actually uses HashiCorp for GitHub itself, or the concept around the cloud operating model and how teams function with this new landscape of both on-premise and in the clouds and multi-clouds even. Chris wrote an excellent blog about how to make sure that you can have a consistent workflow for development teams and operations on GitHub's blog just this month. And then there's some tutorials here about exactly what Justin walked through, as well as his demo code that I encourage you to take a look at and make your own GitHub HashiCorp integration today.
All right. I'm joined by Ray Polsky, Field CTO at HashiCorp, and Justin Juray, Senior Partner Solutions Engineer at HashiCorp. Thank you for both being with us today. Great presentation. We're about to take some Q&A from the audience, so feel free, if you're interested in some of the aspects of what you saw, drop your questions in the public chat to the right of your Goalcast panel, and we will get those questions asked. Ray and Justin, a couple questions coming in at the moment. So is there any security concerns? I believe this is a Vault specific question. With a long-lived OIDC role, is there any additional security concerns? For instance, what happens if that role ID gets leaked? Is anyone able to access your secrets?
Let's see if you can hear me all right. We good, Alexis? Great.
You're good to go,
So,
Ray.
One of the benefits about Vault, we have this concept called dynamic secrets. So you can still store things such as your static secrets you've had in the past, but dynamic secrets allow you to be able to generate credentials wherever they might be and rotate them over time. So you don't necessarily have to worry about having those long-lived credentials. You can fit it into whatever your security posture might be needed for your enterprise. Justin, feel free to pipe in as well if you want to add any color to anything.
No, you're good. I think you've covered that one.
Good to go. Excellent. Here's a question for the two of you gentlemen. Is OpenID available for self-hosted Vault as well, or is it only on the cloud offering?
For both self-hosted as well as the cloud offering.
Excellent. Easy enough there. Oh,
Yeah,
and just for the audience, feel free, if you're asking questions, we don't get to your questions, I do want to let folks know that these sessions are being recorded. They will be shared. You should, as an attendee, as a registrant, get an email from us regarding where this is stored, or you can follow the blog at partners.github.com for our internal blog posts. Okay. Questions are still coming in. Let's see here. So this one, this is a little bespoke. So I'm gonna rely on the two of you gentlemen's knowledge here. This one is very specific for Terraform, specifically TerraGrunt. It looks like we are using TerraGrunt, and we need to integrate with TFC. Would you recommend using GitHub Actions to run TerraGrunt, which in turn triggers workspaces on TFC?
Oh, this is one of those engineering questions. It depends. All depends upon how you want to set up your orchestration process. But you definitely, that's a pattern that you could use to have GitHub Actions invoke TerraGrunt, which then in turn kicks off Terraform Cloud. We see people do that all the time. See other types of ways to orchestrate this as well, but that seems relatively straightforward.
Excellent. Very cool there. For Terraform Cloud, here's a question for the two of you. What are the benefits of using Terraform Cloud for remote state and variables over managing them locally?
Alexis, could you repeat that? I'm sorry, you broke up for me.
No worries at all. What are the benefits that you see for using Terraform Cloud for remote state and variables versus managing them locally?
Oh, I see what the question is. Well, Terraform Cloud, there's a free tier, by the way. One thing that we do make sure of is that Terraform state, which is what records what you declared as part of your infrastructure as code, is held in a highly available and also highly secured area. There's a lot of exploits that we see where people actually hit your VCS or your S3 buckets, pull out your Terraform state, and then gain access to your credentials and can move laterally throughout your enterprise. So as for very little bit of overhead of actually invoking Terraform Cloud for your runs, you get a whole lot of security, a whole lot of auditing for little to no cost, depending upon how large your enterprise is.
Excellent. Excellent. Let's see here. So for deploying Terraform or using Terraform to deploy with AWS, without using your AWS access key or secret key, is that a possibility?
I've been talking too much. Justin, why don't you pick one up?
Yeah, so that's actually what was in fact in the demo there. So in this case, the AWS secret key is it's not in there. You'll see that kind of in the repo. What you do have to kind of be logged in to set that initial IAM roll up within AWS, and you can kind of do that through Terraform. Once that is configured in Terraform, when the Terraform build kicks off, those are the credentials that it's using. So it's no longer using your AWS access key and secret key. So that is in the demo there, and you can follow along with that. I believe I put the links to the documentation for that in the chat, and I believe they're also in the GitHub repo.
Fantastic. And the GitHub repo is for, what can attendees expect out of the GitHub repo that you've shared?
Yeah, so in that repo, we've got everything that you saw today, but I also went through and put in some Terraform code to configure both the Vault side as well as the Terraform side. So there's instructions in there on how to use all of that, as well as links to the docs that I referenced. For Vault, it goes through, will connect to your Vault cluster. In this case, I am using an HCP Vault cluster with namespaces. So if you don't have that and you're using self-managed here or just a dev instance, you might have to go tweak that code to pull out some of the namespacing. But otherwise, you run that configures the Vault side. And then as you kind of saw in that video, where there's just a couple of things within GitHub Actions you need to configure, and then those can talk to each other. So this repo you should be able to pull this down, configure this for your environments with your credentials, and spin this up if you want to play with it yourselves.
Excellent. Be sure to follow along if you can with all the amazing extra functionality our partners are sharing with you today on your own. Here's a question for you from the audience. So we saw some of the benefits of OIDC today. What's wrong with using a Vault role and secret IDs with short TTLs?
Sorry, unmuting there. It's definitely not anything particularly wrong with it. The burden kind of comes on with when you do have those secret IDs. Like, let's say we have the exact same thing, right? You saw in my GitHub repo, I had a secret ID in there. Now, when I generated that, I did that with a long-lived secret ID. If this was a short-lived secret ID, then sure, that works. But now my pipeline is going to fail eventually when that secret ID expires. You just have to stay up on refreshing that. There are ways around that. You could obviously script some of this, but why bother going through that trouble when you can just use OIDC and takes care of all of that for you?
Excellent, excellent. Here's a question coming in. Actually, this is a question for GitHub. So with GitHub Actions, the question originally, with GitHub Actions, is there a way to create template actions that we can share across different repositories, similar to a concept known as shared libraries? I'll take this one myself. There is. So within GitHub Actions, we have a reusable workflows where you can, it's more of a separation of concerns. You want to keep yourself from repeating yourself within your action workflows. I'm going to ask, if I don't get to it myself here in a moment, we can drop a link to our documentation for reusable workflows here in the chat for everybody to take a look at as well. We're approaching the end of our Q&A. It's amazing how much time flies really, really quickly here. I wanted to extend a special thank you to the two of you for joining us today from HashiCorp, and to the entire HashiCorp team for putting together this presentation and assisting with all the materials we've shared with attendees today. Thank you so much for joining.
Nope.
All good. Next up, we have LaunchDarkly and controlling feature releases with GitHub Actions.
Peter McCarron. I'm a senior technical marketing engineer here at LaunchDarkly, and today I'm going to talk to you about controlling releases with GitHub Actions and LaunchDarkly. Before we dive into the presentation, just to quickly cover our agenda, first I'll give you a quick introduction as to who we are as LaunchDarkly as a platform. Then we're going to talk about the build, release, deploy pipeline, so exactly what goes into the process of releasing new features within your application. Then we'll talk a little bit about how LaunchDarkly and GitHub Actions can support you in both of those. And last but certainly not least, we have a nice little surprise that we're introducing today, and then we'll do a quick demo. So for those of you who aren't familiar with LaunchDarkly, we are a feature management platform designed to help you minimize the risk that is inherent to software releases. We were founded in 2014, and we have over 4,000 customers and a little over 500 employees at this point. We also have over 50,000 users on the platform right now. One of the main questions that we often get is, why LaunchDarkly? Why should we choose you as our feature management platform? Well, first and foremost, we built the platform with a developer-first mindset. We're trying to make it easy for application developers to be able to include feature flags into their code and make those flags accessible to other units of your business. Along those same lines, we also want to make sure that we can give you guardrails. We have scalable automated processes that allow you to control how features are getting released and making sure that those features are being seen by the right people first. We also want to make sure we can help you with the entire flag lifecycle. One of the things that can be a little bit troublesome is that you have a whole bunch of flags in your code repository that you need to clean up. How often are they being used? When was the last time they were evaluated? LaunchDarkly tries to provide you those answers through great integrations like our GitHub code references. And finally, we want to make sure that we work at scale. Our platform is able to support hundreds of thousands, if not millions of flags at a time, and we can deliver variations and changes to your applications in under 200 milliseconds. We are truly a feature management platform that was built for the enterprise. To go a level deeper on that, with LaunchDarkly, we're going to provide you the ability to create a standardized and automated rollout practice with one-click rollbacks. That means that if something goes wrong in your code, we can just flip the flag off and you can remove the feature from production without any of your end users being impacted. Beyond that, we give you the ability to create that continuous development process, be able to make a lot of small changes, test them with internal users, and then be able to commit those changes all in a very automated fashion, being controlled through feature flags. And finally, as you're making that progressive migration to the cloud, we can control that migration process through feature flags, making it easier for you to test things before you go live to all your end users. So now that you know a little bit more about us, let's dive into why we're here today to talk about the build, release, deploy process. So when you think about the stages of the application lifecycle, it's pretty typical that you can say that the front end before the actual release to production looks something like this. First, I'm going to build my code, which involves being able to create my new features or build the base code. I'm going to usually store that in something like a GitHub repository. Then I'm going to go through the deploy process, so where I may release those features or release that application to very controlled environments, do some quality testing, do some iteration, and then finalize it. And then lastly, I'm going to do the release process, where eventually I'm going to push it out to whatever live or production environment that I have. And the benefit here is that LaunchDarkly and GitHub can help you at every stage of this process. Starting with the build stage, this is kind of like the bread and butter of GitHub and LaunchDarkly. As I'm an application developer, I write my code, I include my feature flags in it, and then I commit that code to a GitHub repository. Simple, right? If you look at the example that we have here, all we're doing is we're saying, we're going to test out a couple of different themes. Maybe we have a light mode and a dark mode. So we put them behind the flag because we want to see how they look in different browsers or on different screens before we make a determination about which one is the right one for us. So we do that and we commit it to our GitHub repository, and then we move into our deploy phase. So the deploy phase is kind of like, going together with GitHub and LaunchDarkly, peanut butter and jelly, right? Like they're going to really complement each other fantastic. One of the things we can do is we can deploy those changes to a live environment, test our flags out, and then as we mentioned earlier, we give you the ability to integrate with GitHub through a feature that we call code references. What code references are is where I can go back into my flag and see where it is in my GitHub code. Now I know exactly where the feature flags are. So again, you'll see that dark mode flag that we had previously. So if I've landed on a specific theme, I can remove that code and recommit my changes. In the release stage, it sometimes feels a little bit like we're offering a pastrami banana bread cottage cheese sandwich. We don't want to do that because that might severely ruin our reputation. But really what I mean by that is that all the elements are there and things logically make sense as far as having the right components, but something just feels a little bit off. GitHub Actions are fantastic for being able to trigger and release changes based on certain things that you do. So maybe I make a different commit to my main branch and that automatically triggers an action workflow where it deploys the application to my Kubernetes environment. That's seamless. That's great. Along those same lines, I could have my LaunchDarkly flags in there, be able to control variations in my production environment, be able to test new things and then remove them through code references. But really what it feels like is that they're kind of working in parallel to one another as opposed to together as a joint solution. And I think there's a better story that we can tell there. And that brings us to our surprise. I am super excited today to introduce the beta of our GitHub Actions flag evaluations integration. This is really going to help complete that release story. It comes together like pastrami and Swiss on rye. I might just be hungry. This integration is fantastic. What this is going to allow you to do is instruct an action to reach out to LaunchDarkly and evaluate a flag, which it can then be used in future steps or jobs in your action. This means that as I'm triggering that release process, I can use feature flags to control elements of that or have it skip certain steps. When you think about the three main benefits here, first, we have the ability now to pass dynamic flag values into our GitHub action files for use in later steps or in later jobs. That means that I could take a string value or integer value and then use it for something like tagging if maybe I'm doing different iterations within that job file. The other piece is that for those of you who are familiar with actions, you may be using if statements to be able to control different conditions or make sure different parameters are met before a job or a step can continue. We can now do that based on a feature flag value. So if it returns true or false, we could say we're going to skip this step. We could also say if it equals a certain value, or if it doesn't equal a certain value, maybe we skip certain steps. This really gives you control of being able to execute what elements of your action can run using feature flags. And then this really completes that full lifecycle story that we were talking about. Because now what I can do is I can not only include my flags to be able to specify what type of releases I want to have, but I also can then go and use code references to clean up the flags that are in the code that I just deployed. So I have flags on my action, flags in my code base, flags all around. So let's revisit that application lifecycle that we talked about at the beginning. From the build perspective, nothing changes. I can still use LaunchDarkly and GitHub together to be able to commit changes to my GitHub repositories that include feature flags and then run evaluations on that. Where things start to change a little bit is now in that deploy phase. Now I can iterate and I can create certain types of builds based on flag values using my GitHub Actions. I can still do the same iteration we talked about in terms of testing out different variations once I feel good about it, using code references to trip it out, but I can also use this iteration so that as the action builds, maybe there's another flag or certain control or approvals around it. And now from that release standpoint, I have an even better capability. I now have the ability to be able to specify different steps in my actions workflow about which ones I want to have be able to run. I can have certain parameters or certain values get passed from those flag evaluations. There's really a cohesive narrative that we can tell there. So that build, deploy, release cycle works very harmoniously with both products. And so let's think about what this could look like from a full end-to-end automation standpoint, really trying to paint the art of the possible here. So first, let's say I create a pull request and I'm using something like Terraform Cloud with a version control integration, and I have that hooked up to my GitHub repository. So I write some changes, I commit them, and in those changes, I'm specifying the infrastructure I want to build. So maybe it's going to build me a LaunchDarkly project and a Kubernetes cluster that I'm going to use later on. Then I can use that project. So I can use that project that I just created as part of that pipeline to create some new flags and then integrate those into my code. Then once I commit the changes into that code, I can have the GitHub action trigger a certain build type. So in this example, we're triggering a dev build type, and that automatically gets deployed to the Kubernetes cluster that I just created with Terraform. I run my variations, I see what I like, I use code references, I go back in and I pull that information out and I create a production ready build. And I cycle around on that as long as I need to before I'm going to push the production environment to my end users. And so let's dive into a demo about how this all works. In this presentation, we're going to talk about how we can use LaunchDarkly and GitHub Actions to be able to control our entire build, deploy, and release process. Before we dive into the actual demonstration, let's quickly walk through the different screens we're going to be working out of so you know what you're seeing as we're moving throughout the entire presentation. So one of the screens should jump right out at you, something that you may be familiar with. That is our GitHub repository. Specifically, we're in the Actions tab. And as you'll notice, I've triggered a number of different actions while I've been testing and building this demo. Some of them have failed, some of them have been successful. Hopefully, we've got all the kinks worked out, so we'll only see green check marks from here on out. On the left side of our screen, we're looking at our terminal window. And in the terminal window, we're just doing a watch on our Kubernetes pods. So this application is running in a Kubernetes cluster. And as we make those changes, we're going to push those changes to that Kubernetes cluster. So this way we can see them happen in real time. Speaking of our application, on this screen, what you can see is we have our application on the right side here. It needs a little bit of help in terms of new design. We have some dark text on a dark background. We have no splash of color on the background. We have no images. And we're going to use feature flags to be able to control and test some of those variations in our live environment. On the other side of the screen, we have our LaunchDarkly environment. I've pre-populated some flags in here, and I'll show you where they are in the code base in just a moment. But we're going to use these flags to be able to see these live changes. And then once we finalize those changes, we'll be able to go back into our code references and be able to pull those flags out. And last but not least, we have our application code. We also have our GitHub action code, which we'll show here in a second. But basically what we're doing is we've gone ahead and added these flags into our code. We just need to push it up to our GitHub repository, trigger our actions, and watch the deployment happen. So I'm going to go ahead and do that now, where we will have our changes. We'll start the demo. And then we'll flip back over to our action screen and we'll see these changes take effect. So here we are on our GitHub action screen. Our GitHub action is currently running. This consists of 4 different pieces. We have a LaunchDarkly component for flag evaluation. We have a code references one, as well as building a new Docker image and deploying our app to Kubernetes. So as you can see, this is all completed. So let's go over to our application and see what happens when we toggle some flags on or off. We'll notice that nothing has changed. Also, if I flip my flag over here, we'll also notice nothing has changed. It's interesting. Let's go back over to our terminal real quick. You'll notice that something didn't happen. We said we had this watch in place because we wanted to be able to see those pods go live. It does say that it deployed the app to Kubernetes as in this action finished. So why are we not seeing a pod refresh? There's a good reason for this, and it was actually, if you caught it on our last screen, the reason why. You'll notice that I have down at the bottom here this flag that says enable builds of new images. Essentially what we're doing is we've created a flag that allows us to be able to let other actions run in certain ways. So opening up our different builds here, you'll notice that because I had that flag turned off, the build and push phase was actually flipped, so it doesn't run. Essentially what this means is that we never actually built a new Docker image, so even though the action completed, we didn't push something new. This is great if I wanted to be able to control. In my case, I put it as either a dev build or as a prod build. And if we're using a production build right now, before we want to do any testing, we probably want to make sure that we're deploying to the right environment, and we want to make sure that we have some other guardrails in place so we're not affecting our production environments. Going back into this, you'll notice that if we go into the Kubernetes demo, the deploy to Kubernetes also didn't happen. So we essentially didn't build our Docker image and we didn't deploy the image to Kubernetes. So let's go back into it, flip our flag, and then rerun all these jobs to see what happens. So we'll change our flag value. As you can see, we're serving dev build now. So what I'm saying is we should be able to create new images. We're going to rerun all of our jobs. And let's give this a moment to pre-populate and see if we see something different happen on our terminal screen with our Kubernetes pods. So fast forwarding here, we've completed our Docker build. Now we're on the stage where we're going to deploy to Kubernetes. So once this gets up and running, we should take a look at the left side of our screen here where we're looking at our terminal and see those new pods come online. As you'll notice, we see the container is going to start creating. And the new job is up and running, and it's terminating the old pod. And as you can see, our steps have fully completed. Now let's go back over to our application, and we can show what happens when we start playing around with our different flags. So back at our application, let's refresh the screen. And you'll notice that we've had a pretty big change, right? Because now all of a sudden we have a white screen where we used to have a different screen. Now, if we enable our dark mode, all of a sudden we have our dark mode page, and this looks a lot cleaner than we previously did. We can also change our backgrounds, where we now have a nice little splash of color. And we now have Toggle, who's given us a high five for completing our different tasks that we have all available. So as you saw, what we did is we completed the steps. We pushed new change to our application repo. Those initially didn't trigger because we didn't have our enable new images flags on. We then reran things, and it then loaded the new image automatically into our Kubernetes cluster. Let's take a look at the GitHub action file itself so you can understand a little bit better about what we're actually doing. So here we are on the GitHub Action page. If you've used GitHub Actions before, this YAML file probably looks very familiar, but let's walk through the different components so you can understand exactly what we've built here. So the very first thing we've done is we've launched code references. We're going to get to that into just a second, but first we'll skip past it for now. The new one that we've created, or the new one that we've released, is this idea of this flag evaluation. Essentially, what we're asking GitHub Actions to do is to reach out to our LaunchDarkly environment and check for any flag values that may be relevant for future steps in our GitHub Actions workflow. One of the things to note is that if you are going to be using this with something like a React application, you can still use the code references.yaml file to be able to put things in as far as like your project keys, as well as any aliases for flags. So for this one, for instance, because I'm using a React application, I want to make sure that it looks for camel case flags as well. One of the nice things about doing it this way is that we're passing in our SDK key as a GitHub secret. So we're not actually storing this in plain text. We can reference a GitHub secret, and then if we were doing this for a different environment, we could update that secret to use a different SDK key. Beyond that, what we've done is once this is all completed, is we now have this LaunchDarkly flags needs here, so we can run this Docker piece. Docker is just going to get set up, and what we're doing is we have this conditional statement. So if you remember the first time that we ran the build, nothing actually got deployed. The reason was because the value of that flag was returning prod build. And we have a condition in place where we want to make sure that we only run the actual build and push action if it's referring to a dev build. So we enabled that flag. We now are allowing for builds and push because we're saying, hey, we're ready for development and testing. The nice thing is that you could put some approvals in place where if you wanted to, you could have someone sign off before the flag gets flipped and any new images get created. Once we do that, we're storing this into our GitHub container registry. One of the nice things that we can do here is sometimes I may have the LaunchDarkly project already built and I already have the client key, but I don't want to store that actually directly into my application code. Using this, I could actually store this also as a GitHub secret and pass that in as part of the build commands, so it uses an environment variable within the container. Last and not least, we have our deploy to Kubernetes job. This is reliant on both the Docker piece completing as well as the LaunchDarkly flags. The reason is that what we want to do is we want to prevent a deploy if the dev build is not enabled. The reason for this is that if we have prod build in place, what's going to happen is we're going to get an error message because it's going to look for an image that doesn't exist. Because what we've done is we're passing in the same SHA value of the image that we just built to deploy to our new environment. So now we've built our features, wrapped them in feature flags, we've deployed them to a live environment and done some testing on them to decide which ones we like the best. Now we're ready to release this. And the last piece of that might be cleaning up our featured flags in order to make sure that we don't have a lot of them just hanging out in production code. So if we flip back over to our LaunchDarkly account, you'll remember there was a fourth piece that we did, and that was for code references. So we know that the dark mode definitely works best on this application. As we saw, this looks nice and clean. We feel really good about it. So what we can do is we can go to our code references here, and we can find where in our application we actually have the dark mode flag enabled. So we don't need this anymore. So what we can do is let's go back to our VS Code, remove those flags, push those changes, and then we should see it deploy live. So back in VS Code, we're once again looking where we have our dark mode flags because this is where it told us. Remember in our code references, it said it was in the login and then in the to-do page. So what we can do is we can go to the to-do page. We can remove this flag because we no longer need it. We can say that this is going to only be dark mode. Save those changes. We also need to go into the login component where we also have the dark mode flag. We'll remove that flag. Save those changes. Call this, we're happy with dark mode. Push our changes. And if we go back out to our actions screen here, you'll notice that we've already pushed our commit where it says we're happy with dark mode. We'll give this a second and then we'll reload the application. So showing our Kubernetes job is running again. If we look at the terminal on the left side here, we should see our new pods popping up in just a moment. We see our containers are creating, says that it's pending. We'll give this a moment just to finish up. Usually takes about like 10 to 15 seconds to deploy our new version of our code. That's now up and running. If we flip back over to our screen here, we refresh our screen. You'll notice that we still have the dark mode on. And if we go back into the feature flags, and let's say we turn off dark mode now, you'll notice that our application doesn't change. But just to show that this isn't static, let's say we decided that we actually wanted to change our background to the purple. Review and save. You'll notice that we can change it to our purple background. And the reason is because we just removed the dark mode flag, but we left the other flags in place in case we want to do additional testing. Hope you found this helpful. Thanks for watching.
Excellent. Peter McCarron, Senior Technical Marketing Engineer from LaunchDarkly, is with us to answer your questions. Thank you, Peter, for joining us today. Great presentation.
Awesome. Thanks for having me. This was a really, really fun project and demo to put together, so I was excited to get to be a part of it.
Fantastic, fantastic. Reminder to folks, if you're just joining in, if you have questions for LaunchDarkly, if you have something related to the GitHub Actions you saw in the presentation, feel free to drop those in the chat. And also keep an eye on partner.github.com. We'll be posting a blog post with all of the recordings from these sessions and any questions we didn't get to today. Peter, first off, could you re-clarify the difference between flag evaluations and code references?
Yeah, absolutely. And I think that's something that even internally, we had some folks who were kind of like, hey, well, don't we already have an integration with GitHub? And the answer is yes. So code references are really great for when you have code, where you have flags that are embedded into your application code that you may later want to remove. So as an example, like we use the dark mode flag in this demo. I may not want to keep a dark mode flag there if I decide that ultimately that's the right theme for my application. I might just remove it. So rather than having to go back through my VS Code and dig through my files and remember where I put that flag, I can immediately find it by just using the code references integration in the LaunchDarkly terminal. So I can go back, find exactly where it is, make a new PR, and remove that. Flag evaluations are where what we're doing is we're retrieving a value when the action is actually triggered. So what's happening is when the action is executed, when GitHub says, okay, we have this action we need to run because certain thing happened, we push to main. What we're doing is we're reaching out to LaunchDarkly, retrieving the value of a flag, and then we can use that value for different components of our workflow. So in the demo that I did, we had a condition in place where we said we are not going to push to Docker unless the flag equal to dev build. So that's kind of the difference, is kind of pre-action and post-action.
Oh, excellent summation there. Let me ask you a follow-up question here. Because you're, behind the scenes, so to speak, at LaunchDarkly with this, with a lot of interesting adoptions of how to utilize feature flags, what do you think is, or what would you consider some of the hardest challenges you've seen in adopting feature flags?
Yeah, I think a lot of people often have the questions of like, how do I get started with feature flags? Most of the time, like if you're building a brand new application, it's super easy because you're just like, all right, well, I'm going to build this app with flags in mind. And where I've run into challenges, or when I've talked to folks, they say, well, we already have this huge, big legacy code base, like that we're not sure that interjecting like flags isn't going to break everything. And that's going to be like problematic for us. A lot of times what I'll do is I'll kind of suggest like, pick a component, pick something small that you can wrap in a feature flag. And that could just be a very basic kind of Boolean one, right? Like you could say like, we're going to run this if it's true, we're going to run this if it's false. So once you start to kind of get that, like flex those muscles a little bit, it becomes a lot easier to say, oh, you know what? I have this, link for an API call in this one component of my application. Let's use a string value and just pass that in from the flag instead. So it becomes a lot easier. But that first Boolean flag is really a great starting point. And I know that that's one of the things that people kind of struggle with, where they say like, I don't really know how to put new flags into my code. So that's what I did first. So it worked for me.
I hear you. There's a note of empathy in my question there too, as well. Peter, you mentioned in your presentation that approvals could be created before the flag gets turned on, and any new images could be created afterwards. How would set up those type of approvals work?
Yeah, absolutely. So one of the things that we try to do with LaunchDarkly is we know that not everybody should have the power to be able to turn flags on or off with like kind of, without any type of oversight. There may be things where you're testing out some flag changes that might cause breakage. And so you don't want people to turn those values on before they're ready, especially once you start to move those into like production ready code. So we offer approval workflows for those flags. So one of the things we could have done with the flag that I did in my demo is we could have said, hey, when we're turning the flag onto dev build, I actually want someone else to go in and review that change and approve it before it actually executes. And that way we don't run into a circumstance where somebody either forgets to turn a flag off or there's a flag that was changed that we weren't aware of. So that's what I'd recommend is like, if you're going to use this flag evaluation tool for conditional statements, so because you don't want certain actions to run, you can have an approval process in place in your LaunchDarkly dashboard. And then it kind of like removes it a little bit because then maybe not everybody who has access to the repository has access to your LaunchDarkly account. So they can't be their own approvers. You get more eyesight on things.
Oh, excellent. Thank you. Thank you for walking me through that too as well. So here's a question that from the audience may have missed it. How do folks get access to the new beta LaunchDarkly action?
Yeah, absolutely. So it's available now. So you can go ahead and access it. If you go to our documentation, I will drop the link in our chat here. Let me go ahead and grab it again. Let's see. I forgot the tab that it's on, so I will drop it in the chat here in just a moment. Don't want to eat up the time, but yeah, it's available now. You just can add it into your action workflow file. We have instructions on our documentation, and I will drop that link on how you can get started with it.
As a follow-up, where can I find the code that was used in the demo? Is there any links you can share or repos?
Yeah, I gotta go clean up some stuff, and then I will make a publicly available version. I will send that over to my friends over at GitHub, a forked version that has, and we'll include that in the follow-up components where people can test this out for themselves.
Fantastic. Is there, this is also a question from the audience on the billing side of the house, is there any additional cost to using the flag evaluation action?
No. So flag evaluations does not incur an additional cost in terms of like LaunchDarkly seats. We're just doing server-side evaluations. So that's why one of the things you need to pass in here is a server-side SDK key. But yeah, you could store that in a GitHub secret. If you are the admin of your LaunchDarkly account and you want to share that with a repository with folks, like we were saying earlier, who maybe don't have access to your LaunchDarkly account, or you don't want them to have access to the project, you can use that as a secret. They'll obviously get an encrypted version when they run the action.
Fantastic. One last question here. Is there any additional configuration with feature flags and using multiple environments?
So I'm sorry, say that one more time.
Is there any additional configuration needed when using feature flags with multiple environments?
Yeah. So the way it's going to work with the action is that we are using the SDK key. For those of you who are familiar with LaunchDarkly, each project environment has a different SDK key. So if you were running this for like a testing scenario, you were going to use your test environment SDK key. You could go in and update that secret for the production SDK key if you wanted to, or you could set up like a different type of action that's going to call and use the production key instead. So my recommendation would be like really what you're using this capability for is controlling how your action executes. So whatever environment you're going to be running other flag testing in. So if it's your test environment first, use the test SDK. If you're going to use this for flags in production, use the production SDK. So then it's very consistent on how you're using it all.
Fantastic. Peter, I can't thank you and the team at LaunchDarkly enough. A big thank you from the folks here at GitHub for joining us today. And please enjoy the rest of your day, Peter.
Awesome. Thank you so much for having me. And for any other questions I missed, I'll go back in the chat and try and see if I can answer them for you.
Fantastic. Next up, we have Datadog joining us to streamline your GitHub workflows with Datadog CI Visibility.
Thanks so much for joining us today. My name is Cassin Chan, and I'm a product manager at Datadog working on our CI Visibility product. I'm excited to show you how you can use CI Visibility to gain a deeper understanding of your GitHub pipelines as well as your CI tests. So even though CI/CD workflows are relatively ubiquitous, regardless of company size, structure, or workflow setup, the vast majority of organizations have very little or any visibility into their CI systems. And this lack of visibility can actually be quite detrimental to development speed and efficiency. We are seeing that developers are committing code more frequently and shipping smaller changes to various environments in order to discover issues at a smaller scale and much faster. However, the other side of this increased commit frequency is that this adds strain to the CI systems. As your code base grows in size and as your CI system grows more complex, builds can become much slower over time. Debugging test failures can become much more time consuming. Identifying and managing flaky tests can be a nightmare. And frankly, as a developer, you're not getting feedback on your code changes nearly as often. All of this can be extremely frustrating and demoralizing. I cannot be the only one who has spent hours digging through a log dump just to figure out why my build failed. For those unfamiliar with Datadog, we are the unified SaaS monitoring and security platform for dev, sec, ops, and business teams in the cloud age. We help companies understand the true state of their applications as well as their systems infrastructure, and we help them troubleshoot customer issues as well as improve the end user experience. If you do know about Datadog, you probably know us for the 3 pillars of observability: metrics, logs, and traces. But we've been adding products at a relatively fast pace over the last few years in order to deliver visibility into your software throughout its entire life cycle. So part of this expansion is CI Visibility, which was created to improve the developer experience. Historically, Datadog has only focused on monitoring live production environments. But with CI Visibility, we are taking that same production grade observability and we are shifting it left into your CI pipelines and tests. And we think that shifting observability left to catch and resolve application problems earlier in the software development process is critical to keeping your CI system efficient and improving release velocity. So in terms of what CI Visibility actually is, it's a product that can help you streamline your CI/CD workflows and give you visibility into your environment. We have 2 sides to the product: pipeline and testing visibility. The pipeline side gives you visibility into your pipelines, builds, and jobs. We can help you identify leverage points and improve performance and reliability of your system. On the testing side, you can track the historical performance of your tests, identify performance regressions, manage flaky tests, as well as utilize distributed trace views of your tests in order to troubleshoot easier. We focus this around constructs you all are very familiar with: repos, branches, and commits. Our product natively integrates with GitHub Actions and provides you with enhanced visibility around your workflows. So without further ado, let's dive into the product. So to help you get started with understanding the health of your GitHub pipelines, we've created a preset dashboard where all of the data from your pipelines and jobs are accessible. We map GitHub workflows to pipelines and Datadog, and workflow runs map to jobs. This dashboard provides a 10,000-foot view of your entire CI system and is a really great place for both teams and individuals to start investigations into pipeline issues. Right now, I'm looking at my pipelines over the past week, but I can use this selector to change the time frame that I'm looking at. I can also use these filters up top to scope this dashboard view. Right now, I'm looking at my GitHub pipelines, but I can also choose pipeline name, branch name, provider instance, and environment. So let's only look at the main branch. We created this exact dashboard for our own build engineering team at Datadog. After showing it to a few early customers, they really wanted something like this for themselves, so we made this out of the box. In this dashboard, we'll show you things like your pipeline executions, overall pipeline success rate, pipeline duration, duration distribution, as well as your top slowest pipelines. We also have information about your failures, your pipeline failure rate, failed pipelines, accumulated duration, as well as your top failed pipelines. And all of this data is broken down by jobs within your pipelines as well. This entire dashboard is being powered by the underlying individual pipeline executions or workflow runs, which means that you can click on anything inside of this dashboard and, as a part of your investigation, drill down to the exact pipelines and the executions that you're interested in. We've typically seen that with our customers, their build, platform engineering, or SRE teams will use this dashboard as their single pane of glass into the entire CI system across many different teams. And they'll usually clone and filter this dashboard to create bespoke versions for individual product development teams. This makes sure that as a developer, I have access to a tailored dashboard for my team so that I can get quick feedback about my CI resource consumption and identify any regressions or areas for optimization. This promotes a culture of proactively maintaining the health and efficiency of the CI system. So navigating to our list view, Here we see all of our pipelines across all of our different projects with information about the default branch, including the number of executions that occurred in the last week, the failure rate, average and P95 duration, as well as information on the last build for this pipeline. You can sort these various columns to pull up your most active pipelines at the top, your pipelines that fail the most often, or your slowest pipelines. So this view can really help you find the pipelines that deserve your attention the most and identify high-level trends in your pipeline performance. So let's sort this by failure rate and look at a pipeline that has been failing more often. So right now I'm looking at a pipeline or GitHub Actions workflow. And this is an overview page that'll show me high-level information about this pipeline overall, aggregated over all of the individual runs. I can quickly access the latest execution at the top. And I can also see information about the total number of executions, failure rate, as well as the P50, P95, and max build durations for this pipeline. And as always, I'm looking at this in the past week, but I can change this picker up here. The great part about having all of this information inside of Datadog is that I can always export these visualizations to monitors, dashboards, notebooks, and incidents. Below this, we have a job summary table where for each of your jobs or individual workflow runs, you can see how long they took, how long they spent in execution, as well as their failure rate. Our product development teams at Datadog really like to come into this job summary table, sort it by failure rate, and quickly see all of their most problematic jobs that caused this pipeline to fail in the last week. Here, I can easily identify outliers and patterns in my executions for this pipeline. It looks like this one has been failing a lot. And in the table below, I have access to all of the underlying raw execution data. So let's say that one of my workflow runs failed and I want to know why. We can click into one of these rows here. And we represent your pipeline execution or workflow run as a trace. So at the top here, this root span is your pipeline, and all of the spans underneath represent the specific jobs and stages that ran as a part of this pipeline. The flame graph view makes it really easy to see what ran sequentially and what ran in parallel, and so that you can identify any major bottlenecks or places for optimization. If I select a particular span in this graph, I can pull up this drawer and I can look at the span tags section, where I can look at all of the associated GitHub Actions metadata or Git metadata for the span. For example, I can see information like the pipeline ID, pipeline name, the URL if I want to go directly into GitHub for this pipeline, as well as commit information such as the author email, date, and commit message. We've seen that some teams will like to add custom tags and metrics to their pipelines. So if you want to track things like code coverage or Docker image size, or if you only have particular pipelines that certain teams own, you can tag by team as well. And all of those custom tags and metrics will show up in this section. If we're using both the pipeline and test functionality, I can click on this test runs tab right here, and I can see all of the test runs that ran as a part of this particular pipeline execution. If I filter by failed tests, this makes it easy to pull up the details of any failed test and figure out why this failed as a part of the pipeline. Or I can look at the test service name and notify the people responsible. So that was all great. I'm looking into a pipeline, but what if I just want to see all of my workflow data in one place? From there, we go to the pipeline executions page. In this executions page, I can see every execution across all of my pipelines. So all of your GitHub Actions workflow data will live in this page. I can find particular executions I'm looking for by filtering based on pipeline metadata or Git metadata. I can also look at this data at different levels of granularity by clicking at the selector at the top. We can also jump into the analytics view right here if I want to quickly create visualizations of my data. For example, if I want to know which pipelines are contributing the most to errors, I can filter by CI status, error, aggregate by pipeline name, and choose the top list visualization. If I want to find the top failing jobs, I can similarly, instead of aggregating by pipeline name, I can aggregate by job name. Another example is that if I wanted to see the P99 duration of my pipelines, I can just remove the status filter, still aggregate by pipeline name, but instead of looking at executions, look at duration and then select %99. So it seems like for the vast majority of my pipeline builds, they're taking about an hour to build. If I want to be able to alert on this or save this for investigation later, I can always export this to a monitor, dashboard, or notebook. When it comes to setting up this integration, it's quick and simple, especially for GitHub Actions. So after logging into Datadog on the side, I can look at the CI section and click on Getting Started. I can click Instrument a new pipeline, and after selecting GitHub, you can see that I have the choice to enable an account. If I go to my specific account, I have the ability to enable CI visibility for my entire account, which means that I will monitor all of my repositories. Or if I only have specific repositories that I want to monitor, I can select it for the repo there. Really quickly within GitHub, if you go to a particular repository and go to the Settings tab, under Integrations, you'll have to make sure that you have a GitHub app installed and connected to Datadog through our generic GitHub integration. So next, I want to cover how Datadog can bring deeper visibility into your tests. Testing generally plays an outsized role in pipeline health, and this is why we decided to have both pipeline and testing capabilities. As with pipeline visibility, I'll go over the setup for this at the end, so let's just jump directly into the testing side. So within testing visibility, this is our default branches view. If you are a build engineer, engineering manager, or team lead, you can use this view to identify any high-level patterns in your default branch. So here we show a list of all of your different test services. A test service is just a user-defined name that represents a group of test suites that all test the same thing. So usually we'll see that a test service maps one-to-one to a repository, but if you are working with a monorepo, you may have many test services for a single repository. In this view, we'll show you information about the default branch, such as the number of flaky tests that we've identified, as well as the P50 and P95 wall time. We define a flaky test as a test that both passes and fails for the same commit. Whether these retries are done through the testing framework automatically or from a developer manually retrying a build after it fails, which I'm guessing many of you have done after seeing a test fail, that's what we use as a signal to determine if a test is flaky. Wall time is the real-world elapsed time that it takes for a test to run. So if you were to parallelize your tests, these numbers would go down. At the right here, we also show you the status of your latest commit along with the commit author and other Git information. We pull all of this commit and Git information from the .git folder. Clicking on branches allows me to see every branch across every single repository. So as a developer, I can use the My Branches toggle up here to quickly filter down to only the branches that I've committed against. And then in this view, I can see the status of all of my latest commits to all of my feature branches. I can see how many tests failed, passed, or skipped, and more. So if I had a test suite with 50 tests and retried it against the same commit 3 times, we wouldn't show 150 tests, we would only show 50 tests. So all of this is aggregated at the commit level. I can also see if my feature branch is introducing any new flaky tests not yet seen in the default branch. At Datadog, using this new flaky test information, we view any feature branch introducing new flakiness as a blocker to merging to staging or default branches. This allows us to maintain and raise the bar on the quality of our tests because it's just much easier to address a flaky test when it's first introduced, as opposed to coming back months later when the person who wrote the test might not even be working on the code base anymore. We also get to see the wall time of our feature branches and how they compare to the default branch. So this is great because I can know ahead of time if I'm about to introduce a performance regression into the default branch before I merge my commit. So let's go back into the default branches view and look at a particular test service. If I want to look at my test service at the branch level and I'm interested in proactively improving it, we can look at this overall branch overview page, which will show me information about all the historical commits for the given time frame that I'm interested in. So much like the pipeline side of the product, this gives us a high-level overview of the test service for this branch. We can change the branch and the time frame at the top, just like the pipeline side of the product. And we can see the test results for the latest commit. Looks like everything was green. We have a table of the past commits and their test statuses. And if you're interested in the historical test data of the branch, you can look into this commits table. We can always click into a specific commit. So I'll just show a quick example of a commit. So we're really aiming to support both reactive and proactive use cases here. There's the proactive use case, which is when you care about optimizing and improving the overall health of a given service. Amazing if you're proactive about this as a developer, but I'm looking at the team leads and eng managers here. But there's also the reactive use case, which is where a commit is failing or has introduced a regression and needs to be debugged by a developer. This view caters to that reactive use case. My commit is failing and I want to see why so I can fix it and merge it as soon as possible. Here I can see a high-level overview of my commit, including the Git information, the test status, as well as a comparison to the default branch. So it looks like this commit is introducing a regression. I can also look at my failed tests. So Datadog will give me any particular error types or messages that they've identified, which can help me figure out why this commit failed. I can also address any new flaky tests that have popped up in this commit and earn myself some brownie points. Below that, I'll see the performance of my tests and how their duration has changed over time. It seems like compared to my previous commit, my tests ran a little bit slower overall. If I'm using the pipeline side of the product, I can also see the related pipeline executions against this commit. And I can quickly jump into the details of that particular execution. At the bottom of the commit overview, I have access to all the test runs that ran as a part of this commit. So that's what the commit overview page shows you. And this can really come in handy when you're just trying to merge into main, especially at the end of the day. But going back up into the rest of the branch overview, underneath that commit table, we have a section all about flaky tests identified for this branch. So it looks like we don't have any new flaky test runs, which is great, but we do have some known flaky test runs. For each flaky test, I can see information about how long the flaky test took on average, the time and commit in which this test first flaked. So I can be reasonably sure about this commit being the one that either first introduced the flakiness or was involved in the code change that did, as well as information about when this test last flaked, the number of commits it flaked in, and the failure rate. All of this information can help me prioritize which flaky tests I should pay the most attention to. I'm sure that for a lot of people tuning in today, you've dealt with flaky tests, you know how pesky and annoying they can be, and maybe you know that they can pop up pretty frequently. We know that it's not a matter of fixing every single test right now. It's a matter of triaging and fixing the ones that are causing you the most trouble on an ongoing basis. Not all flaky tests are created equal, so these are here to really help you prioritize. Let's say I identify a test that fails more than the others. If I know that I fixed it, I can manually remove it from this table. But also, if the test hasn't flaked in the last 30 days, Datadog will automatically remove it for me. So this will really help me manage my flaky tests on an ongoing basis. We know that flaky tests can be extremely frustrating. As a dev, I have seen myself really slowly start to lose confidence in the test that I write and just hit retry more and more often, hoping that the test will pass. This sort of behavior, while not ideal, is unfortunately pretty common. And over time, not only is it harmful to engineering culture, but it also leads to a decrease in the performance of the overall CI system. Below the flaky test, we have information on your test performance so that you can see your slower tests that are potential candidates for optimization. And this is all still aggregated at the branch level. If I want to be a standout engineer, I can look at the top slowest tests and improve them. And through Datadog, I'll have proof that I made this test faster. I can also see the most common errors for this branch within the chosen time frame. Every time a test fails, we capture the error type. So if there's a common underlying root cause leading a lot of your tests to fail over time, that'll be surfaced here. Our devs at Datadog use this branch overview page quite a bit, and they've seen some great results. They'll come in on a weekly basis. They'll tackle the 3 to 5 most flaky tests, as well as their slowest tests. And over time, they've been able to really increase the quality and reliability of their tests, as well as reduce their testing time. One of our teams in particular did a really great job at reducing the number of flaky tests in their code base from 16% down to 2.5%. And they cut down their total testing time by 40%. That's just simply way less time spent sitting in front of your computer waiting for your test runs to finish. The other significant impact we saw here is that by improving flaky and slow tests, we were able to boost our pipeline performance. Our testing stage tends to be the flakiest and longest running stage in our pipelines. And so we see a lot of that benefit across the CI system. At the bottom of this branch overview page, we have access to all of the underlying raw data around my specific test runs. So what we'll do now is we will visit a flaky integration test. View last failed test run. And in this trace detailed view, we can see the distributed trace created by this test. And we do this by auto-instrumenting the specific languages and test frameworks that you use for testing, as well as common libraries like HTTP, SQL, and gRPC. This distributed trace is quite powerful for debugging integration tests. So just to help break down what we're looking at here, the root span of this trace is the test itself. If I click on it, I can see all of the details on the information that we're collecting about this test. I can look at the CI metadata, the Git metadata, author, commit SHA, and repo. I can also see the particular configuration as well as the runtime details. Coming back up to this graph here, underneath the root span, we see all of the other spans generated by this test request. So you can see that this test reached out to many other services. We can see the breakdown on the right of the execution time spent per service, and I can also toggle this to see the number of spans that were generated per service. This flame graph is really helpful for identifying dependencies, bottlenecks, and really help provide additional details and context so that you can understand exactly what happened during a test request. This flame graph can help you identify dependencies, bottlenecks, and provide additional details and context just to help you understand exactly what happened during a test request that maybe wouldn't be captured by your test harness. This makes solving complex test failures much, much easier. If I'm trying to debug this integration test and there was a dependency service throwing an error 500 for a test against staging or production, I can immediately see which services were likely the culprit in causing a test to fail, instead of wasting my time trying to reproduce this failure locally and after the fact. We can also jump to the errors tab down here to see all of the errors thrown during this test run. If there is a stack trace, we'll collect it and surface it here to make for faster debugging. Clicking on the performance tab up here gives me the historical performance of this test over time, so I can see if a test is getting faster or slower over time. Once our developers at Datadog had these kinds of tools, they started to think about their tests a lot more proactively. When you have this sort of visibility, you can get ahead of these issues. As a developer, I want to be able to show my stakeholders or my manager not just the impact of my changes, but the sustainability of that impact. And I can use these sorts of views along with dashboards to do just that. One feature that we recently released that a lot of our customers have been loving is test summaries and GitHub pull requests. So from any commit or branch overview page, which I just showed, I can enable test summaries in my GitHub PRs, which will automatically post information about failed and flaky tests directly as PR comments. Most of us use GitHub a lot, and with this, we can more immediately know our test results and act upon them, whether that's in GitHub, Datadog, or both. So in terms of getting set up for test visibility, we can go to the same getting started page as before, click on instrument a new test service, and then choose the language or framework for your testing. If you are using Swift or Objective-C, we actually recently created a GitHub action that will automatically instrument your tests for you. So if you are a mobile developer, you're in luck because setting this up would be easier. But as a catch-all, if we don't support your specific language or framework, you can always upload JUnit XML tests to Datadog. Most of these frameworks will allow you to export your tests in this format, and then you would just be able to send these reports into Datadog. So I know that was a big walkthrough, but I hope you enjoyed it. And if not, at least hopefully you could see new areas where shifting observability left and earlier into the software development lifecycle is beneficial for everyone. I'm really excited to see how you all can begin using GitHub Actions with CI Visibility to improve your CI performance, reliability, and efficiency. Let's open it up for questions.
Excellent. With me now is Casson Chan, Product Manager at Datadog. Thank you for being with us today, Casson.
Thank you for having me.
Just a quick reminder to all attendees, as always, thank you for joining us. These sessions are recorded, so you will have a recorded link sent out via your email used to register for the event. We'll also be posting these on YouTube. And additionally, if there's any questions that we don't get to in this live Q&A, we'll be sharing that out as well. Look for those announcements as we reach the end of the broadcast. Casson, we have some questions coming in from our attendees today. Let's jump in.
That's good.
Can Datadog's CI Visibility show the time spent with a pipeline queued versus the time spent executing for GitHub Actions?
Yes, that's a good question. So in that flame graph view that I showed, we are able to show the time spent during execution, and that's broken down to the granularity of your entire workflow run or jobs or steps below that. So you'll be able to see the execution time. We are actually currently working with GitHub to be able to surface queue time in Datadog as well.
Oh, fantastic. That touches on a little bit of a follow-up question here. Am I able to see the queue depth within that same visibility tool?
So queue depth is something that we're also looking into. Today, you wouldn't be able to see it in the product, but hopefully in the future, yeah.
Fantastic. Here's a question from Nate in the chat today. I noticed that billing for the CI and pipeline visibility tool is based on multiple of the number of committers to a repo. I apologize, a multiple of the committers to a repo. Is this still the case, or there are alternatives to billing?
Yes. So this is still the case. We bill based on the number of committers for any of the monitored repositories in a given month. So the way we look at a committer is we will find the number of unique Git author emails that are pushing commits. And if you commit 3 or more times with a particular email, we'll pick that up as a committer.
Excellent. Thank you, Nate, for that question. For these visibility tools, are you able to configure this at the organization level or enterprise, or is this per repo?
Yeah, that's a good question. So for GitHub in particular, you can choose to configure it for your entire GitHub account. So all of your repositories associated to that account, or you can only choose to monitor a particular repo if you have particular ones that you care more about. There's that granularity there.
For the CI tooling that you demonstrated, is this something all Datadog customers have access to, or if not, how do we get access to that?
Yeah, so CI Visibility, there's 2 parts to the product. One is pipeline visibility and one is testing visibility. Pipeline is the side that natively integrates with GitHub Actions. Test will also work with GitHub, and all of that Git metadata will be available inside the product. So these are products that sit on the platform as separate SKUs. So they are purchased separately, but they all are a part of the platform and integrate with dashboards, notebooks, and more.
Excellent. Here's a bit of a configuration question. For the Datadog GitHub app, is that something that has to be enabled to get test summaries for pull requests, or is this using actions? Essentially, how do we set this up?
Yeah, so for enabling GitHub test summaries, I don't think you actually have to be using GitHub Actions. So as long as you're using GitHub for your source code management, you'll be able to set this up. And I will paste the documentation link in the chat.
Excellent. So we saw that you could look at the test service at the repo level, but is there a way to look at these types of reports at the environment level?
Interesting. So right now, the way that our views inside the product are set up are they're revolving around commits and branches. We are thinking about having more perspectives because we know that you are interested in looking at this data through a variety of different lenses. So that is something that we'll take into account.
When you're parsing action runs, is there a specific type of data that should or you would like to be sent from GitHub Actions to Datadog for these dashboards?
Yeah, that's a good question. So the way that we integrate with GitHub Actions is this is a native integration. So we work directly with you guys to pull specific pieces of data that we think would be valuable for customers. So this is where that queue time spent in execution, failure rates, duration, all of that comes in. In terms of sending custom data, we're working on ways to allow customers to say, I want to send a specific piece of data that maybe GitHub isn't actively sending to Datadog right now. But if you do have something specific that you're looking for outside of what is natively being sent just automatically when you set up the integration, that's something that you can submit a request for.
Fantastic. With the CI visibility tool, again, that you demonstrated here just a moment ago, are you able to pull data from that into other Datadog dashboards? And if you are able to pipe that data across the Datadog platform, are there any docs or resources that you can share on how to do so?
Yes. So all of our dashboards can take in data from any source that Datadog has. So you can mix CI visibility, pipeline test data into a single dashboard along with any other product that you're using. So that can be very easily done. In terms of dashboard guidance, we do have documentation around different widgets and best practices for how to put together our dashboards. But generally, a lot of our products will have out-of-the-box dashboards. So the one that I showed towards the start of this was our out-of-the-box pipelines dashboard that showed your GitHub pipeline data. And a lot of our customers will like to use that as a jumping off point. So you can clone that entire dashboard, create your own mix and match widgets, copy and paste, basically customize to your heart's desire.
Excellent. I do like optimization and customization. Here's a follow-up question here. Out of curiosity, what promoted Datadog to develop this type of tooling? Is there a specific set of pain points that you were observing with the Datadog customer base, with or without having this tool?
Yeah, so the backstory for this is actually quite interesting because this product, actually, the team behind it came to Datadog through an acquisition. And the reason for acquiring this is because we felt like there were a lot of pain points around pre-production visibility. Traditionally, when you look into a pipeline failure, or if you're trying to figure out why your build failed, you are largely looking at log dumps if you even are caring about this at all. And that can be a very time-consuming process. And what we'll see is that a lot of issues that we're noticing in production could have been caught earlier in the software development process. And if you catch those issues earlier, then the cost and in terms of the amount of time and effort will be much lower. And so we're thinking that if we're able to really shift this observability left into early in the software development lifecycle, that would result in a lot of gains for everyone, really.
Fantastic. One last question for you today, Casson. Is there any design recommendations for creating these types of dashboards within Datadog?
Yeah, so we try not to be too prescriptive with dashboards, but in product, you'll see that when you set up a dashboard, there are a lot of tooltips and things like that that'll tell you about what each widget is really meant to be for. That documentation link that I sent will also be helpful. But generally, I think the best thing to do is to look at those dashboards and then create a copy of it, play around with it, spend some time understanding what you might want a layout to look like. And really, it should be designed around the data that you care about the most, right? So if you're only interested in a particular branch or a particular pipeline or specific metrics like failure rate or job failure rate, putting those in ways that are immediately visible and actionable to you or your team or whoever you're creating the dashboard for, I think that would be a good place to start.
Excellent. Casson, thank you so much. And a big thank you to the Datadog team for sharing this with us today. Please enjoy the rest of your day.
Thank you. You too.
Up next, we have democratizing AI by reducing cloud costs and time to production with OctoML.
Hello, I'm Vanessa Yan, and I'm a staff product manager at OctoML. Today, I'll be speaking about how OctoML and GitHub are making artificial intelligence accessible to more developers by reducing cloud costs and time to market. I'll start by introducing the problem space. Then, I'll describe our recommended solutions while grounding them in real-life case studies and developer success stories. Finally, I'll show you a demo of how you can use our solutions directly within your GitHub CI/CD pipelines. The field of artificial intelligence has gotten a lot of attention in industry these days, thanks to the sticky user experiences built around models like Stable Diffusion and ChatGPT. However, AI remains inaccessible to many developers due to the high cloud costs and engineering effort required to deploy models into production. Machine learning models are getting larger and larger these days. For example, a generative text model like ChatGPT can cost millions of dollars to run every year once your application starts getting traction. Startups can't afford to spend their entire seed round on running a model in production. And even large enterprises are facing pressure to be more cost efficient in the current macroeconomic climate. Second, even if developers are able to stomach the cost of running AI, It can take months of engineering effort to get a trained AI model into production. Lots of teams come to OctoML looking for a way to expedite their time to market. And finally, after launching a model into production, teams continue to encounter difficulties in scaling up their infrastructure to serve all user requests because of hardware allocation shortages on the cloud. Most developers don't have the expertise to implement workarounds. And at the end of the day, managing infrastructure distracts developers from building the models and the surrounding applications. Let's take a deeper dive into generative AI as an example. Imagine you're a developer that is using large language models to create a chatbot that helps job seekers prepare for interviews. Your app goes viral, and at the end of the year, you get 1 million daily active users. If inference costs are about 5 cents per conversation, the total bill amounts to more than $6 million in just year one. Unlike fine-tuning or training costs, which are upfront expenses, inference costs are a sleeping giant because they increase infinitely with model usage. If you're a developer deploying a similar large language model as the backbone of your new application, your entire pricing structure and business model must take these costs into consideration. By the time your AI application launches, training is more or less a sunk cost, but inference costs rack up forever. Fortunately, there are automated tools we can use to solve this problem. We recommend 3 ways to reduce inference costs. First, DIY your own API deployment to avoid overpaying for capabilities you don't need and being locked into price increases due to the reliance on others' API. Apart from price benefits, you also get more ability to customize the model to your use case. Second, you can reduce cloud costs by optimizing your model so that it runs faster on any hardware. There are many specialized compiler and ML engineering techniques that can be used for this purpose, but they can be hard for data scientists and app developers to grok. The OctoML platform helps you automatically sweep over all these techniques and give you back an optimized version of your model so that you don't have to worry about doing the work yourself. Let's take a look at how this works in practice. Let's say you want to deploy GPT-J into production. On the A100s, there's a $46 million annual cost difference between a non-optimized GPT-J model and an OctoML optimized version, assuming your application has conservative usage and receives only 230 inference requests per minute. This case study shows why it's important to optimize your model before you launch into production. Even the difference between the most optimized package and the runner-up on this chart amounts to $4 million a year of cost savings. Finally, to reduce inference costs, you should also take the time to identify the most optimal hardware that meets your latency SLAs and build your service in a way that enables you to easily port over from one hardware to another for maximum cost savings. Let's go back to our GPT-J case study to show you an example. We first tried deploying GPT-J to an A100 GPU with 40 gigabytes, which yielded the lowest latency, but that didn't turn out to be the option with lowest cost per inference. Also, A100s tend to be in short supply on the cloud, so you need a backup hardware option in order to scale up for higher inference loads. Another option is a lower-end GPU like A10, which cannot run GPT-J out of the box, but with a few OctoML-provided modifications, you'll be able to fit your model onto this hardware. The latency here is nearly as fast as on the A100s, but the cost is by far the cheapest. The last option is to run on a high-memory Ice Lake CPU. This is not an ideal choice because it causes the latency of every inference request to be higher. But if you can't get sufficient allocation for GPUs, you need to use this option as a backup. On this chart, you see that moving from A100s to A10s could save you $2 million a year, for a slight trade-off in latency. This huge impact on the bottom line is why hardware portability matters. Now, if we put all three levers together, DIYing your own deployment using automated tooling, optimizing your models to run faster, and picking the most optimal hardware, you can save a lot of money. To give you an example, one of the developer team's OctoML serves was using a large transformer-based model like GPT in production. This team's application serves hundreds of millions of global users, and the team was paying millions of dollars per year to run this application. With the help of the OctoML platform, this team was able to achieve 33% cost savings. That means for every $1 million they originally spent running inferences, they ended up paying less than $700K instead. Cost savings of this scale can make or break a business, especially if you're a developer team that is just starting to leverage machine learning and don't have millions of dollars to splurge every year. All right, now that we've ensured the unit economics of building an ML-powered application is in check, let's move on to talk about accelerating time to market. While training machine learning models is an important process, we need models to actually land production in order to start getting user engagement and revenue. Many developers come to OctoML telling us that deploying a model into production is an arduous process that can currently take them multiple months. Deploying a model to production can be broken down into two main aspects. The first is obtaining an API that exposes the functionality of the model. And the second is to call that API in the rest of the code for your web, mobile, or other application. Most developers are already familiar with the second part of calling an API within an application. The difficult part is getting an API that runs your machine learning code on production-grade servers in the first place. Right now, certain companies that have already built APIs to serve models have either kept their APIs behind closed doors or asked for a non-trivial amount of money and sacrifices on data privacy for other developers to use these APIs. As a result, developers are looking for open source implementations of popular models and trying to make their own APIs around these models. The goal of OctoML is to provide automated tooling so that you can get an API out of any trained model in minutes rather than months, and ensure that you can leverage this tooling directly within the CI/CD pipelines you're already used to in your day-to-day software development process. Last but not least, developers find that machine learning applications in particular are difficult to scale because these applications are extremely compute heavy. Developers need multiple GPUs to run a model like Stable Diffusion, even if you only have a handful of users. When the application starts getting traction and you need to scale up to hundreds or thousands of GPUs, you bump into GPU allocation shortages on the cloud. This is a problem because machine learning code is often written with an assumption that you would have access to the GPU. Having to switch the code dynamically to run on CPUs is not something that most developers know how to do. That is why OctoML builds our automated deployment tooling with scale in mind from the get-go. We handle all the complexity behind the scenes to give developers hardware independence so that developers can rest assured that their application will always be available, no matter how popular it becomes. Having said all that, let's jump into a demo to see how you can leverage OctoML and GitHub Actions to launch an AI model into production with reduced cloud costs and time to market. I've now navigated to OctoML's public GitHub repository called OctoML CLI Workflows. This repo gives you an example of how to deploy machine learning models into production within your automated GitHub CI/CD pipelines with the help of OctoML CLI and GitHub Actions. Let's go down in the README to understand this process at a high level. The first step is to commit your model to GitHub after training the model or finding an open source pre-trained model. Then create an OctoML.yaml file following the example provided in our GitHub repo. This OctoML.yaml file tells the OctoML CLI which model you wish to run in production and which hardware options you'd like to deploy on. If you want to scale up your service with independence across hardware options, you should list multiple hardware targets here in the YAML. For example, instead of specifying Skylake only, you can specify A100 GPUs, A10 GPUs, as well as a CPU option. Third, create a GitHub workflow YAML file based on our template titled cloudexample.yaml in this repo. This file essentially runs a series of GitHub actions to deploy a container that you can run inferences against on the cloud. Finally, once you have the workflow YAML file defined in your repo, simply open a pull request to trigger the workflow. That's the high-level idea. Now, let's take a deeper dive into what our GitHub Actions workflow file looks like. First, our workflow performs the typical GitHub actions of checking out the repo and pulling Git LFS. Then, we need to download the OctoML CLI and log into our Cloud Container Registry. Here we use GitHub's Container Registry as an example, but you can change this part to utilize AWS, GCP, Azure, or any other cloud registry of your choice. You should also make sure that the access token for the OctoML platform and your container registry are stored as GitHub environment variables in your repo secrets. Next, we get to the part where the deployment is done via the commands OctoML package and OctoML build. Package creates a Docker file and a version of your model that's been optimized to run faster with lower costs on any cloud hardware of your choice. Build generates a container based on the Docker file, and this container comes with an inference server that exposes the functionality of the model. In other words, this server has a port that you can send live traffic to on the cloud. Afterwards, we run Docker push to push our inference container to the cloud registry. This step is compatible with any downstream infrastructure service you may already be using for the rest of your application, such as Cloud Kubernetes services or serverless offerings like Lambda. Alternatively, if your application is brand new and you don't have any of this infrastructure set up yet, you can also reach out to OctoML for us to automatically host and scale all the infrastructure for you in a serverless way. Finally, open a pull request to trigger the whole GitHub Actions workflow. When we navigate to the Actions tab on the GitHub UI, we can see here that our workflow deploys a model to production on the cloud within about 6 minutes. To recap, what we've done here is run a GitHub Actions workflow that automatically deploys a model to the cloud while ensuring that the model runs with lowest cost and lowest latency in production on any cloud hardware of our choice.
And staff product manager at OctoML, Vanessa, thank you for joining us today.
Thank you for having me.
Vanessa, excellent presentation. OctoML is obviously in a forward area, we'll say, of the tech space. What are a few best practices to keep in mind during the development of an AI model that can help save costs once that model has finally been deployed into production?
Yeah, so your question is about post launching a model into production, right? And one main thing to keep in mind there is the ongoing costs you're incurring for inferences. And that bill can rack up really quickly, especially if your application is becoming successful and getting lots of users. So we recommend that as you watch your inference costs, make sure that you're using all the tooling that's possible to keep those costs down. So for example, in the presentation earlier, I touched on how there are tooling you can use to make your model run faster on any hardware, so that you're shortening how much energy and how much time your model is consuming on the cloud, and thus lower your cloud bills. And then two, make sure you're on the right hardware in the first place, so that you're not cornered into the situation where you're overpaying and then trying to go back to your cloud vendor and say, oh, can you give me a big discount because I can't really afford to spend that much money on my inferences.
Excellent. Vanessa, I have a follow-up question from the audience. Are there any limitations for what types of models can be deployed with OctoML?
Honestly, not really. Our goal is to just give you the ability to bring in any trained model, be it from open source, be it something that you train on your own, or something you fine tune on top of other people's kind of existing foundation. Like those are all okay to bring into the platform. We have various use cases that we can support across computer vision, natural language processing, really kind of any major use case you can think of. And then we also support models of different sizes. So, from smaller models like ResNet for vision or the largest generative AI text models, like those are all within our wheelhouse.
Excellent. Here's a popular question, a theme that's been coming up to a reoccurring theme is billing. How much does using the OctoML action cost? Are there fees associated with getting access to the CLI tooling that the action utilizes?
Yeah, so if you go navigate to the examples GitHub repo I sent you, there's a link to just sign up and use that immediately for free. This is kind of free up to a point where you can optimize your first model, and then after that, if you feel this tool is right for you, you can come talk to us and basically have us figure out how much money we can save you, and then we take a cut of that kind of cost savings. It's certainly free to start using.
Excellent. That is exciting to know. Here's a question from the audience. How does using different GitHub runners impact the speed of the OctoML action? For example, using what we refer to as our larger hosted runners, and would like to know if this would generate even more cost time savings.
Well, generally, the process of getting an optimized version of your model back and deploying that is very fast. As you can see in the example I showed, it completed within 6 minutes or so. So that optimization process is very quick, no matter what runner you are on. When you're talking about which hardware, which runner you're using to serve the actual inferences in production, the larger the GPU, the faster your inferences go, but it's not necessarily the cheapest option when you pick a larger GPU. We've seen, A10Gs, T4s do pretty well. And then we've also been testing AWS Inferentia as another example. I'd say the hardware space changes pretty quickly. There's always new hardware that comes out. And, part of OctoML's job is to continuously test the latest and greatest, and then basically help you automatically leverage the best kind of hardware using our platform.
I want to key in on something you just said. It was a reoccurring theme in both the Q&A and your presentation, which is referring to inference costs as the sleeping giant, increasing indefinitely with model usage. Could you explain and clarify why this is the case and how OctoML can help us address these issues?
Yeah, I'd say historically, not a lot of developers even get to the point where they're experiencing these costs because of how hard it is to deploy any model in the first place. In the last few years, we've seen the largest enterprises being able to do that after months of work. But, in recent months, actually, the rise of these popular models like ChatGPT and Stable Diffusion has gotten the rest of the world around to try to deploy models now. And more people are facing this problem. And they realize that, fine-tuning and training costs, that's a one-time expense. But after your model gets into production, your bills add up every day and actually every second that a user makes an inference request to your service. And that's why we consider that a sleeping cost. A lot of people don't even think about modeling their inference costs before their model lands in production. And that's a big mistake because once you have a model in production, then, switching your model over to a different hardware only at that point is suboptimal, right? You should have done that before your model even got to production so that you're not overpaying.
Makes sense. You also mentioned oftentimes scaling a model in production can be hindered by not having the ideal compute to run on. Could you touch on what exactly would be the ideal compute to run these types of models on? Would it be such as a topic we just touched on a moment ago, having access to the proper number, let me rephrase, a certain number of GPUs?
Yeah, I'd say the answer is actually different for every model. Hence the need for automated tooling that helps you explore the different hardware. Right. So, for some models, you need an A100 GPU with 40 gigabytes. For others, you need A100 with 80 gigabytes. For others, you might not need an A100. You might want an A10G, like the GPT-J example I gave. Or for other models, maybe CPUs is sufficient. The answer varies case by case. So the point is that you should take in your trained model, and then before you take it to production, let's make sure you have the right hardware in mind that you want to deploy to, and then deploy it to production. And when you're thinking about scale, right, you have your most kind of cost optimal hardware that you'd like allocation for. Then you might need some backup options if your application is of huge scale, right? So we have customers come to us and say, okay, I've identified through OctoML that A10G is my most optimal hardware option, but sometimes they start bumping into allocation shortages, and that's happening across all three clouds. We actually partner very closely with each cloud provider, and they tell us, sometimes they really just don't have enough hardware to service everyone's request. And in those cases, you do need to be able to kind of seamlessly migrate some of your inference workloads to the second and third hardware on your list of preferences.
Makes sense. Totally makes sense. Question from the audience. Can we enable GPU sharing for inferencing via OctoML?
Yes. So that's the type of work that OctoML wants to do for you. If you are a customer that chooses to go through OctoML optimization process and then deploy on your own kind of Kubernetes or serverless system, we can work with you to make sure that GPU sharing is happening. Alternatively, if you want us to completely do the work for you, you just want an API back and you want us to kind of orchestrate everything, that's certainly something we can work with you on as well. In fact, we're going to launch a new platform that kind of makes that serverless orchestration functionality available to everyone pretty soon. Right now, it's still kind of in waitlist mode. That you can certainly access it if you talk to us, but over time, we're going to GA it and open it up to more folks.
Excellent. Vanessa, I can't thank you enough for joining us today, and the entire team at OctoML for the presentation and all the materials you're sharing with our attendees. Thank you to you and your team.
Thank you, GitHub team, for having us.
Have a good one. Today, we've seen a fraction of the capabilities offered by GitHub Actions. HashiCorp showed us the ease of deploying infrastructure, both securely and reducing engineering overhead. LaunchDarkly presented the flexibility in managing your feature releases, while Datadog empowers you to observe every facet of your GitHub pipeline. Lastly, as we move into a new era of AI development, OctoML revealed the power of abstracting hardware concerns. GitHub and our partners are on a shared mission to create a more secure and efficient development lifecycle. We're always engaging partners to bring you more of what we showcased today and the power GitHub Actions can bring to the table. I'd like to extend a special thank you to everyone in attendance from the Technology Partnerships team here at GitHub. If you're interested in learning more and engaging with GitHub to utilize the capabilities presented today, or consuming integrations from any one of our many partners, please reach out to us. There is our button at the top of your screen on the right side, partner.github.com, or any one of our many social channels. Thank you for joining us today, and let's build from here.